So today we're going to be talking about 1.5, but before we even get to 1.5, I want to challenge you guys with this question or exercise for a rational expression. In this case, it's not a rational expression what I'm about to give you. It's actually a transcendental expression or an irrational expression. I encourage you guys to try this out, this problem right here. So take a time, pause the video if you need to, and give this a shot. The whole point of this is supposed to be simplifying. So I'll give you a few seconds. All right, if you attempted it, you might think, hey, this problem right here seems kind of funky to deal with. Well, I'm going to tell you, you need to factor things when you're simplifying. You cannot cancel this 1 plus x and x plus 1, even if it's the same as 1 plus x, because there's a subtraction symbol. Remember, the whole point of simplifying or canceling things out requires us to only have multiplication between two giant objects. However, there is a subtraction between our objects, so we have two terms, and I cannot do that. I need a single term for my numerator. So what I can do initially with the numerator is GCF. If I find the GCF, we can say they both have 1 over x. But the problem is, hey, what exponent are we dealing with for the GCF in particular? And the exponent, generally speaking, is always going to be your smallest exponent. So in our case is negative 1/2. And I know we're not comfortable with dealing with negative exponents or fractional exponent for GCF or anything of the sorts, but you need to get used to it. So if we factor out this negative 1/2, I'm going to use a bracket to make sure we don't get confused with parentheses. They're going to mean the exact same thing in our case. Just I want to reduce the amount of confusion in particular. But we're going to have left over 2. And now I need to know what happens if I take away this term. If I were to take away this term, what is remaining left? Well, if we go back to our examples, let's say x to the 5th, 6 divided by x to the 5th. We're going to be subtracting our exponents. So in this case, we have the exponent. We have the exact same base. We keep the same base. However, our exponent is going to be whatever is 1/2 minus negative 1/2. That's going to be our exponent. And then we move to the second term. Well, I'm not going to affect this x at all, so I keep the x. However, in this portion right here, we're going to have 1 plus x. And this is going to be negative 1/2 subtracted by negative 1/2. And this is all going to be over. Oops. This is all going to be over. And instead of x plus 1, I'm going to rearrange it in a way where we're comfortable with that with our problem. I'm going to rearrange it as 1 plus x. And I can do this because, hey, addition is commutative. I can rearrange the terms. And I can also add a parenthesis. That does not change the problem at all. So if you calculate this out right here, you're going to have for your numerator 1 plus x to the negative 1/2 power, all multiplying, and 2, 1/2 minus negative 1/2, that's going to be x to the first power, minus x times, well, negative 1/2 minus negative 1/2, well, if I'm doubling the negatives, so you can think of it as distributing over, or I like to turn it into addition if I see two subtraction symbol. That's going to be 1 plus x raised to the 0th power, all over 1 plus x. And then you're going to simplify this into 1 plus x 1/2 multiplied by 2 times 1 plus x minus x. This turns into 1. All over 1 plus x. What did this do for our problem? Well, if we notice, besides what's inside the parentheses, we actually only have one term for the numerator. There's two factors, but because it's multiplying, there's only actually one single term. And if there's only one single term, you can cancel things out. But the problem is, this doesn't have the same exponent. So we can't cancel out cleanly. It's the same example as x to the 6 over x to the 6. They will cancel out. However, x to the 6 over x to the 5th, it does not cancel out cleanly. Instead, we have to subtract the exponents. So if we subtract our exponents, this is technically an exponent of 1. And then we're going to have 1 plus x raised to the negative 3 halves. Negative 1 half minus 1 is negative 3 halves. All times 2 raised to the 1 plus x minus x. And we got rid of our denominator. This gets deleted. So now we can deal with that negative exponent. So if I deal with it, I have 2 times 1 plus x minus x all over 1 plus x raised to the 3 halves power. And in the last part, we got to distribute and combine like terms. And I'm giving it as exercise for you guys to figure that out, but you'll eventually get x plus 2 all over 1 plus x raised to the 3 halves power. Boom. These are the type of questions that I kind of expect you guys to be able to do once, or not expect you guys to be able to do, but on any sort of test or assessment, I will have a couple of questions that require a lot of skills or fundamentals, and it might not be exactly what I have shown you, but it'll be something that I am assessing. So these are the type of questions over here. It's not going to be exactly what you see on homework, but it might be relating to the homework in some way, just something that you might have not seen before. So now we get into 1.5. And 1.5 is all about solving equations. And the root word of equation is the word equal sign. So in particular, we're going to be using the equal sign. And this means numerically equivalent, or logically equivalent if it's logic we're working with. But logic would use arrows, but it's numerically equivalent. So we got covered a few definitions. And for the first definition, I'm going to cheat a bit because I'm not actually going to give you a definition. Instead, I'm going to give you words that are synonymous to the word. So let's talk about solutions. A synonym for the word solution is going to be roots. And another one's going to be zeros. And then we also have x-intercepts. All of these words are synonymous. So if you know what one of these words mean, you're good to go. You know what each of these words mean. The one that you might not be comfortable with is zeros and roots. But they all mean the same thing. So once we have that, now we can go with, our last two definitions we'll talk about today. The last two definitions are going to be linear equation. And I'm just going to make up some letters. So A comes first, and then the letter B comes next in the alphabet. So a linear equation is in the form of ax plus b. So it's a polynomial with degree, remember what the word degree means, 1. And if you don't, it's just the highest exponent. The highest exponent for your x is going to be 1. So example, 3x minus 4 equals 0. The highest exponent is 1. This is a kind of a form that you might see a linear equation in. I said it equal to 0, but not all linear equations are set equal to 0. So I'm just using this as, an example. The next definition we're going to cover is a quadratic equation. And a quadratic equation is similar to a linear equation, except instead of degree 1, we have a polynomial with degree 2. So this is going to be in the form of ax squared plus bx plus c equals 0. And you might think of an example. Examples are easy. 3x squared plus 4x plus 10 equals 0. Let's see. I always have issues with this. Equals 0. Boom. So these are the definitions we'll be working with today, these equations. Now, we need to move with solving linear EQ. Solving linear equations. Well, let me give you an example of one. You might see 7x minus 4 equals 3x plus 8. Now, when you're dealing with linear equation, you always got to know what your goal is. In our case, our goal is to have all x terms, not just the x terms to one side of equation and isolate it. So when I say one side of the equation, if we look at the equal sign right here, we're going to look to the left and to the right. The problem is we have an x here and we have an x here. These are our terms. We have an x term and another x term. One on the left, one on the right. I got to be able to only have one term. So how can we actually move all the x's to one side of the equation? Well, we have to move an entire term. We can't just move individual pieces in our term. We cannot just move the 3 without the x. So to move a term, remember terms are separated by addition and subtraction. So to remove a term, we have to undo what's happening with that term. And in our case, we have addition. So to move a term, move term, add or subtract. You're going to subtract 3x to both sides. So let me erase that little horizontal line so it doesn't cause any confusion. Let's subtract 3x to both sides. If you do something to one side of the equation, you got to do it to the other. So now, if I subtract 3x to both sides, let's look on the left side of the equal sign. Notice that we have like terms. Our like terms are 7x and 3x, minus 3x. So we can combine those two together. So if we combine those, we get 4x minus 4. And then on the right side, plus 3x minus 3x, that's going to give us 0. Not 1, 0. It's 0 because when we cancel out, we're doing addition and subtraction. And that makes our cancellation 0 instead of 1. So we're left with just 8. Now we have to move this term because x, although they're all on one side, to the left side, they are not isolated. So I have to get rid of this guy. So I have to add 4 to both sides. I have to move that term over. 4x equals 12. And now at this step, we are done with moving terms. There is no more moving terms at all. Now we got to get rid of operations that are happening to our x term. So we're not going to be really adding and subtracting anymore, no matter what the problem is. In this case, we're actually going to get rid of the 4. We can't really move it. However, we can cancel it out. And to cancel this out, this is multiplication. To undo multiplication, you got to divide. So we got to divide both sides by 4. And if we do that, 4 divided by 4 is 1. So we're left with x. 12 divided by 4 is 3. That is our solution. That was our solution, our roots, our zeros, all of that good stuff. Now I encourage you guys to try, or this little exercise. 2x plus 10 equals 2 times x plus 5. That's one exercise. And the other exercise I encourage you guys to try. 2x plus 10 equals 2x plus 3 halves. Try that out. If you try these out, you're going to get some weird answer. I'll let you know that. So go ahead and try that out. Pause it if you want to. And then get back to me in a few seconds. I'll be back. All right, now that you have tried the problems out, if you get this, eventually you're going to get x equals x. Or you're going to get, I don't know, a number equals a number. You're going to get something crazy. You might get 10 equals 10. That's a possible answer you might get. What does this mean? That means all solutions work, or x is all real numbers possible. Boom. And in this case, right here, in this problem, you're going to get something like, I think it was 10 equals 17, which is clearly not true, so that means there's no solutions. So, in these cases, there's 3 different types of possible answer for a linear equation. You have, oops, what's happening? Well, I'm reconnecting. I apologize for that. You have x can equal 3. You have x can be a real number. and you can have no solutions. So those are the three types of different answers. You can have either one solution, infinitely amount of solutions, or no solutions for a line. And the reason why is that if you graph it on the plane, a linear equation is just a line. And remember, this is the x-axis over here. It's the y-axis. So in this case, we don't touch the x-axis at all. So I mean, there's no solution. In any other case, we have either one solution, or if I'm drawing my line on the exact same x-axis, there's infinite amount of solution. That's the intuitive idea of why there's this many solutions. In particular, I want you to keep track of this solution though. This is the most important one. A single solution. So next, we go into quadratics. Quadratics. Solving quadratic. And remember, it's in the form of ax plus b x plus c equals 0. Well, to solve a quadratic, there's different methods, but let's just take an example so you guys can figure out what methods we might use. And though I never introduced you how to solve this, you guys can get kind of the idea of how to solve it. So if we look at this and look at our definition puts it in the equals 0. So why not try to set it equal to 0 first? If you want to set it equal to 0, you need to move this guy away. And the only way to move that guy, it's a term. Technically there's a plus sign here. I have to subtract 24 to both sides. Now, on the left side, there is no like terms at all. There is no like terms. I cannot combine the 24 with the 5x. I cannot do that. So if there's no like terms, you cannot combine them. You have to leave it the way it is. And then 24 minus 24, they are like terms, so that's 0. Now we have it in our definition format. And then something you should notice when you're looking at this problem is the fact that it has 3 terms here. This is called a trinomial, and if you remember from trinomial, we can factor. So, real quick, the factors of it is going to be x plus 8, x minus 3, and I hope you guys have been practicing that. So, now, notice we have this equal to 0. It is important you set this equal to 0. And the reason why is that we can use our 0 property rule. 0 property rule states that a number times 0 will give you 0. So the only answer, or the answer that you want to think about to equal 0 is, notice that this is all multiplication. If one of these giant groups are equal to 0, and then we have solved our problem. So what will cause this giant group to be 0? What value of x can I plug in, add 8 to it, and give me 0? If you guess negative 8, you are right, because negative 8 plus 8 gives me 0. Over here, if you guess 3, you're done. If I plug in 3 minus 3, I get 0. 0 times any number is 0, so my answer will work. So, your answers are x equals negative 8 and 3. Boom. So if you can solve by factoring, then you're good to go. This is why we did so much practice on factoring. If you look on the discussion board, I hope you have tried that out, then you can be prepared for this unit. And rational units, of course. We did a lot of factoring in rational units. Factoring is just the easiest method. Now, we got to go with completing the square. And with completing the square, there's a lot of things I can talk about it. But before I even go with completing the square, first you have to understand the idea intuitively. So first, let's see. X squared plus 8x plus 16. What are the factors of that? Try it out. What are the factors? If you guessed x plus 4 times x plus 4, which is x plus 4 squared, you are 100% correct. Now let's try x squared plus 10x plus 25. Well, if you tried that out, you get x plus 5 squared as your factor. X plus 5 times x plus 5. The factors of 25 that adds up to 10 can be x plus 5. Now let's even go even more. I want you guys to kind of get the rhythm of this. What if I had x squared plus, or I'm not even do plus this time, minus 22x plus 169. This should give you, oh, not 169, I apologize, 121. This should give you x, not plus 11, x minus 11, because there's a minus sign. You have to pay attention to that. So then the question is, how am I getting these answers so quickly? Am I just square rooting these guys? Well, if I square root this guy, how am I going to get negative 11? If you guess that you should divide this by 2, then you're golden. All you had to do was divide each of these by 2, and then automatically that tells you these values. So that's not hard. So let's go into something that it can be more challenging. Let's say I gave you only x squared. Let's say x squared minus 4x in this case. And I told you to find that perfect square factor. Well, if you tried that out, you would be confused because you need this last piece. However, you might start arguing it's x minus 2 already. X minus 2 squared. So you're almost there, but I'm missing this last piece. If I had the last piece, it would be x minus 2 squared. So we know we're supposed to have x squared minus 4x, and then it's supposed to be plus 4. We know this is what we need. However, what did I do with the red problem? I took away that plus 4, right? So when I go over here, from here to here, I took away that 4. So what do you think I have to do with my new factored form? I have to do the exact same thing. If the original took away that plus 4, I have to subtract 4 out of here. Otherwise, they're not the same value. These two should be equal to each other. And because this guy was missing that plus 4, then this guy is also missing that plus 4. And this is how I can get rid of that plus 4. So this process is called completing the square. This is called completing the square. It's the process of being able to factor it. Even though it might not be a perfect square, you get a factor that's a square, or you get a factor that turns your problem into a perfect square as close as possible. And I say close in quotations because I never told you what the word close means or meant. So you can try these examples on your own time. You could try x squared minus 10x. Or you could try x squared minus, I don't know, 20x. See if you guys can get that. Or plus x. And if you tried that out, it's not too bad. You would have something like, what is that? X minus 5 squared minus 25. And how did I get these values so easily? Over here, we got minus 4. Well, the idea is that to get this value, you divide this guy by 2. To get the minus 25, you just got to square this guy right here. Square that guy and subtract it off. That's it. So I encourage you to try that out. And now we got to move on. So now, what if instead I gave you a problem like this? X squared plus, let's do 8x. No, I don't do 8x. I don't like 8x. Let's do 12x minus 3 equals 0. Oh, when you look at this is not a perfect square already. This looks confusing. And I asked you on this problem, complete the square to solve for the quadratic. Oh. It is equal to 0 in this case. It is equal to 0. You don't have to set completing the square equal to 0. So let me actually erase this. You don't have to set it equal to 0. You can, but you don't have to. If you're a person who likes to set everything equal to 0, perfect. Factoring, you do have to set it equal to 0. Completing the square, it's more flexible than that. So let's say I put this as, let me think, 13. All right. So on this problem right here, to complete the square, these guys may mess you up. They might confuse you. I'm going to say ignore them for now. Just complete the square how you would normally. If you would do If you would try to complete the square regularly, this would become x plus 6 squared. And then what are we subtracting off? Well, we're subtracting off 36. And now just drop these guys down. Just drop them down. So then you get minus 3 equals 13. Well, nice. Nice. Now, the goal of completing the square, solving quadratics by it, is not setting it equal to 0. Because we're not going to be using our 0 property rule. Instead, we're going to solve for x. Solve for x now. Solve for x. When you complete the square, you're solving for x. So, to solve for x, I got to combine like terms first. X plus 6 squared minus 39 equals 13. Now, you have all of this. There's a lot of operations happening. Now, when you do cancellations, when you're trying to do some cancellations, or solving for x generally, you have to do the reverse process of order of operation. So normally you would say you do the parentheses in first, then you do your exponent, then you do all that stuff. Reverse that. You're doing parentheses, what's inside the parentheses last. Then you're going to do your exponent next, or second to the last. So the thing that you have to do first in this problem is add 39 to both sides. What is happening? I don't know what's happening. I guess my internet's bad. So once you add 39 to both sides, you have x plus 6 squared equals, what is that, 52? Great, 52. Now I have to get rid of this guy right here, the exponent. Well, to get rid of that guy, use square root. But there's a problem. You can't just square root. I only half told you the truth. Let's take an example, square root of 9. We know the square root of 9 is 3. That's always true. However, this is a different statement than saying, what number squared gives me 9? They're two different statements. The square root of 9 assumes that you're only going to be asking for the positive. However, if I use this statement, technically speaking, I have two answers, negative 3 and positive 3. Because negative 3 times negative 3, well, a negative times a negative is a positive, so it should give me 9 as well. So when you square root problems, you're not just going to get the positive answer. You got to get both. You got to get both the positive and the negative. So we say plus or minus square root. And if you square root both sides, plus or minus square root both sides, these guys cancel out. So you're left with x plus 6 equals plus or minus square root 52. The square root cancels out the square. So giving you guys a heads up, it cancels out raising to the second power. All right. This means you have the negative and the positive square root 52. Well, we're almost done. However, I do need to simplify this real quick. I do need to simplify that. Let's simplify that. So if I factor tree, I get 26 and 2, 13 and 2. And then our index is 2 for square roots, so we're going to circle this. So our new problem is going to be x plus 6 equals, oh, where do I put the 2 at? That's a good question. Well, the 2 has to be multiplying our square root. So you're going to have plus or minus 2 root 13. 13 is your other prime number. So don't put the plus or minus between the 2 and the square root. You got to put it before. If you mess that up, then you're turning it into 2 plus square root 13, which is not true. It's got to be multiplying. Now, we got to solve for x. We're almost done. X, to get it by itself, we subtract 6 to both sides. However, are these like terms? 6 and 2 root 13? No, they are not like terms. So you cannot combine them. Do not combine. Your calculators can combine them. I don't like the way your calculator combines them, but you cannot calculate them, or you cannot combine them in our case. So we're going to leave it as negative 6. Remember, the negative stays with the 6. Plus or minus 2 root 13. The order doesn't really matter, but I like to put the negative. I like to put the integer first, and then the irrational number. This is an irrational number or a transcendental number. So that's our first problem that we solved via completing the square. Sometimes you won't be able to factor treat things nicely. Boom. And this is the main way you're doing it. Now, if you noticed, if you ever forget to put the plus or minus square roots, here's one key way in figuring it out. Well, in our original problem, our degree was 2. That's our highest degree, or highest exponent. The degree is 2. Well, it turns out that your exponent represents the number of solutions. Besides the case where we talked about the linear where we have no solutions or infinite amount of solutions, it generally will represent how many number of solutions you will have. So in our case, we should have 2 solutions. So if you forgot to put the plus or minus, you're going to realize, wait, I only have 1 solution. This is bad. I should have x equals negative 6 plus 2 root 13. And I should also have x equals negative 6 minus 2 root 13. These are my 2 answers. You can write this form right here. I'm just scared some people will forget the plus or minus. That's it. So as long as you're understanding of that, then you're good to go. Now we gotta go into another method. So this is another method. Now, you can use any of the methods to solve quadratic equations. So far we have factoring and completing the square. The problem about factoring is that you're lucky if you can factor. If you can factor, it is the quickest way. And it's also the one with the least mistakes. So I recommend factoring when possible. However, sometimes things don't play out nice and you have to complete the square. So this is why I encourage you to keep practicing some problems on that in your book and everything. So moving on. The last one is completing the square. And this next one are the surefire ways of always working. But they are also the ones that causes the most mistakes. So this is called quadratic formula. Formula is different from equation. Formula is a rule. Equation is more so a form. This is an actual rule. The quadratic formula is x equals, and then it's going to be, there's a song to it. I'm not sure if you guys have ever heard the song, but I'm not going to sing the song. But if you guys remember that, then good for you guys. It should be negative b plus or minus square root, and then you're going to have b squared minus 4ac all over 2a. That is the quadratic formula right there. And in particular, these letters and variables, they correspond to your quadratic equation. Your quadratic equation is in the form of ax squared plus bx plus c equals 0. So if I give you an equation, let's say example, don't get them confused. Let me use a different color. Let's say I give you 3x squared minus 5x minus 1 equals 0. No, you have to be equal to 0. You have to be. So you notice completing the square does not require you to be equal to 0. However, quadratic and factoring does. So we have to set it equal to 0. Now, I encourage you guys to figure out what A, B, and C are. They will always have value. If you don't see the values, put a 0 there if you don't see them. But they should always have a value. In our case, A is 3, B is negative 5, and C is negative 1. And then all you're going to do is plug it into your formula. So we're going to say our x is going to be equal to, if I put into my formula, I have negative b, negative of negative 5, plus or minus square root negative b squared, minus 4 times a, which is 3, times c, which is negative 1, all over 2 times 3. Boom. Oh, why did I write b? Ah, no. How did I just erase the b by itself? Let me see. I don't think I can do that, can I? Well, I'll just fix it up then. This is supposed to be a 5 square root. Boom. Negative 5 square root. You have to, I recommend using parentheses when you input these in so you don't make the mistake. because a lot of people will forget about this right here. A negative over a negative, or negative times a negative. So once you simplify, you have negative of negative 5. It's a negative times a negative. You get positive 5 plus or minus square root. Negative 5 times negative 5 is going to give you positive 25. You'll always get a positive number here, by the way. Just giving you a heads up. 25 minus, so let's see. Let's look at this carefully. Let's put the negative on this 4 and turn this to addition. I like to just do it that way. Remember, that's the exact same thing. If I say 3 minus 6, that's the same thing as saying 3 plus negative 6. It's the exact same thing. I do that so I don't make the mistake when I multiply things out. So if we do that, we have plus negative 4 times 3, which is negative 12, times negative 1, which is positive 12, which I can just write 12. See, in that way, I don't make that mistake. I did not want you guys to make that mistake. So all over 6. And then if I simplify this, we get x is equal to 5 plus or minus square root 37 over 6. And I can't factor tree this. 37, I can't really factor tree. 37 is prime, so there's not much we can do. So this is simplified. This is perfectly simplified. So this is the example of using the quadratic formula. And then they go into discriminant. So if you want a definition, I'd recommend you write this down. So this way, this word is not new to you. The word discriminant is going to be everything here. That's your discriminant. It's going to be b squared minus 4ac. It's everything under the square root. That's what we call a discriminant. And it tells you the behavior of your answer. If your answer is going to be a real number, if your answer is going to be one answer, it tells you all of those information. Circle this. So that covers the quadratic formula. So we covered many ways to solve a quadratic. We said factoring, which you have to set it equal to 0. We said completing the square, which you can set it equal to 0, but you don't have to. And then we have quadratic formula, which you do have to set equal to 0. So for your sake, I'd recommend, if you can't remember completing square can do both, tell yourself, just put everything equal to 0. That makes your life easier so you don't make mistakes. And if you're comfortable with just knowing that completing the square does not have to be equal to 0, fine, go ahead. So we got to go into the last one. So in 1.5, they have two more topics, but we'll cover those at another time because we don't really. Those will come back in chapter, I believe, 3. I want to say. Let me see real quick. Just real quick in my little agenda. Yeah, it should come back in chapter 3. So we are fine with that for now. And you guys already know what domain and everything is. So yeah, chapter 3 is good enough for that. So the last thing that I want to talk about is solving for 1.5. Solving rational equations. Solving rational equations. So let's take the equation 3 over x minus 2 over x minus 3 equals negative 12 over x squared minus 9. Woo. This is a big one. There's some little tricks we could do, some little shortcuts. However, this might be annoying. And it's because this is a rational expression or rational equation. When we do rational or radical equation, you always have to consider domain at the end. Consider domain at the end. When you plug things back in, you consider your domain. So, before we even consider our domain, let's actually try to solve this out. And we're going to treat it like how we can subtract things together. When we subtract or add, rational expression, we want the exact same denominator. So let's multiply each of these fractions to get the same denominator. I'm going to factor out everything so it's easy to understand, but let's write it out. If I were to factor this last part, it's going to be x plus 3 times x minus 3. Now, the question is, what can I multiply each of these They might be different numbers or values. What can I multiply each of these terms by to get the exact same term? Well, if we look at the first one is missing an x minus 3 and an x plus 3. So I can multiply the first one by x plus 3, x minus 3, over x plus 3, x minus 3. I can multiply the first one by that. Good. The second one, well, this is subtraction. Let's put the subtraction, let's turn it into addition, but turn the subtraction to negative, or turn the problem to negative. That way I don't deal with subtraction. I hate dealing with subtraction. The second one has an x minus 3. It is missing an x plus 3 and an x. So why not multiply the second one by x times x plus 3. X times x plus 3. And this is going to be negative 2 all over x minus 3. And then the last one, it has x plus 3 and x minus 3. It's only missing this single x right here. So I can multiply that by x over x. And I'm going to have negative 12 all over x plus 3, x minus 3. Now, I encourage you not to actually, I highly suggest you do not expand the denominator. You only have to expand the numerator. Only the numerator. So before I even expand the numerator, let's actually try to calculate the numerator, or let's actually write it under one fraction. So I have x plus 3, x minus 3 times 3 plus x times x plus 3 minus 2 equals negative 12x. I'm just going to multiply that last one out. And then they all have the same denominator. This is an equal sign. So let me actually, I can't do that. Let me stop at the equal sign. Boom. They all have the exact same denominator. Well, this is actually very nice. This is a very nice problem now. And the reason why I say it's very nice, notice the denominators are the exact same. When their denominators are the exact same, in mathematics, if I multiply once to one side of the equation, I have to multiply the other so to stay the exact same. Well, what if I multiply both of these, the left and the right side, by x plus 3, x minus 3 times x? I'm not dividing that, I'm just multiplying this out. I change the value of this guy. However, if I multiply this guy by it too, I change the value of that guy. So x plus 3, x minus 3, all that stuff, right? I'm multiplying both sides by our denominator without having to divide it out by that denominator. If I do that, this problem becomes easy. And why? They cancel out completely. So essentially, once you get the same denominator, you can ignore the denominator. Once you have your fractions or your rational equation, it has to be an equation, it has to have an equal sign, you can remove your denominator completely. That is very nice. So I don't have to worry about my denominator at all. Now I just have my numerators. So I have x plus 3 times x minus 3 times 3 plus x plus 3 times negative 2 equals negative 12x. And then we got to move all the x's to one side now. The problem is, I got to distribute. Sucks, you got to distribute. If you distribute this guy over, boom, 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 and then do the 3 as well, you're going to get, I'm not even sure if I can do this in my head, but I'm pretty sure it's going to be 3x squared, and then what is that, minus 27? Is that right? Verify it. Plus, and then what is this one right here? Negative 2x squared. And then what is that? Minus 6x equals negative 12. Boom. Combine like terms. This is like terms with this guy. And then those are the only like terms. And then you get, what is that? X squared minus 6x minus 27 equals negative 12. And we're almost done. We're almost there. We're almost there. Don't worry. We are almost there. The issue with this looks like a trinomial, but Remember, we have to set it equal to 0 to solve for a quadratic. Solve quad. This is a quadratic because the exponent is 2. So I got to set it equal to 0, which means I have to add 12 to both sides. If I add 12 to both sides, I get x squared minus 6x. What is that? Minus 15 equals 0? Well, now I can factor. I get x. What is that? Does that factor out nicely? It may not. I do not know. I don't think it factors out nicely. Let me just check real quick. It was a mistake somewhere. Ah, I see. There was a mistake. I apologize. This was negative 12x. That's the reason why. So I have to add 12x to both sides. I knew I went somewhere wrong. Otherwise, it would have played out nicely. So this is actually plus 12x. So this is not minus 15. This became instead... Erase. Oh no. Oh, my computer is lagging at the moment, as you can tell. How do I fix this? Ah, there we go. So, it's going to be instead of minus 6x, since we're adding like terms, we have a different like term because of that error. We're going to have plus 6x minus 27. And then if we factor this out now, this becomes, what is that, 3 and 9? Plus 9 times x minus 3 equals 0. And then our answer, solution, x equals negative 9 and x equals negative 3. Be careful. Oh, I'm negative 3. Be very careful. Not answer yet. Be careful. This is where a lot of people make mistakes in math, and this is where all the contradictions happen when people try to show people proofs. This is not the exact answer yet. And the reason why is because if we look above in our problem, we have to consider domain. Remember, you cannot divide by 0. So if your answer is 0 right here, if your answer is 3, if your answer is 3 or negative 3, then it's incorrect. You cannot have those values as your answer, your solutions, because they would cause the problem to divide by 0. You would have an error. Now, in actuality, you're supposed to actually plug in your solution back into the original equation. So I encourage you guys to try to plug it back to the original equation and see if it works out. See if you get something like 6 equals 6. Where's the true statement? But you cannot divide by 0, so for these problem right here, we cannot have this as our answer. X equals 3. If I plug in 3 to my original equation, right here, I'm going to have, 2 divided by 3 minus 3. I'm going to have 2 divided by 3 minus 3, which is 2 divided by 0. Automatically, you messed up. That is indeterminate. So your only solution is this guy. X equals negative 9. You have to check it. You have to check it. You have to plug it back in. And this is the same when you're solving square roots. Like when you're solving square roots, let's say I have 2x equals 1 minus square root 2 minus x. If you're solving something like that, well, first you got to move the square roots to one side to solve for x. So you got to get rid of this minus 1, and you have 2x minus 1 equals negative 2 minus x. And then all that jazz. I'm not going to go into detail because we'll talk about that another time, chapter 3. But the idea is that you do have to check your solution, so I apologize for that. Now, getting to the final part of this section that we're going to be talking about is... Where's that? Oh, that was the final part. Yeah, that was the final part. The other parts I can cover next time, but that is the idea. That is the idea. And 1.5 talks about absolute value, but we'll cover that at 1.8. So don't worry too much about that. But that's it for solving equations for now. Yeah. That is it for solving equations. But if you guys, let's just actually bring the problem because now it's irking me a lot. Let's just do that real quick. 2x equals 1 minus 2 minus x. We'll see this later on, but I might as well show it now that it's bothering me. So, subtract 1 to both sides. You cannot combine like terms, so you have 2x minus 1 equals negative 2 minus x. And then, well, I don't want to just move this guy. I want to get rid of this guy now. I've already moved enough. I already moved enough terms. Now we actually want to solve for x. So I got to get rid of this. Well, how do I get rid of that negative? I can multiply both sides or divide both sides by negative 1. Divide both sides by negative 1. And if I do that, or multiply by negative 1, if I do that, you have to distribute that guy over here and over here. So we're going to get negative 2x plus 1 equals root 2 minus x. And then to cancel square root, well, if we square root to cancel out square, the reverse is true. So why not just square both sides? Boom. And if you do the math over here, what are you going to get? You get, what is that? 4x squared minus, let me show you this so you don't make the mistake. Some students will make this mistake. When you're squaring this, you actually have to expand it. You can't distribute this x part like some people think. No, you have to do negative 2x plus 1 times negative 2x plus 1. This is a very common mistake. Equals, and because this is one term, inside the square root there's two terms, but if you look at the outside, it counts as one term. I can actually square it. So if I square it, this thing cancels out with this. Boom. So I have 2 minus x. And then if I simplify this or expand it out, you're going to get 4x squared minus 2x minus 2x plus 1 equals 2 minus x. And then you get 4x squared minus 4x plus 1 equals 2 minus x. Then move all the x's to one side. And this is a quadratic, so we want to have equals 0. So we're going to add x. And we're going to subtract 2 off. We want to move it. We don't want to solve for x yet because it's very hard to solve a quadratic for x. We want to move everything. So if I do that, minus 2 plus x over here, I can combine like terms. I get 4x squared minus 3x minus 1 equals 0. All right. Now in this portion right here, you can actually factor this out. So, to factor this out, this is a method that I didn't go into too detail about factoring. We'll cover it another time. But, let's see, do I want to cover it now? No, I'm not going to cover it now. But in this case, I'm just going to complete the square. Oh, the complete square is rough here. You can do quadratic formula here as well. But, to factor this out, we multiply this value with this value. If you guys watched the interactive video, then you have negative 4, and the factors of negative 4 that adds up to 3, negative 3, are going to be negative 4 and 1. And then now you're actually going to express this as negative 4x squared. Instead of this minus 3, you're going to write down minus 4x plus 1, plus 1x minus 1 equals 0. And then you're going to bring out grouping, if you remember what grouping is. Boom, boom, boom. And then if you find the GCF of each group, you're going to have 4x here. And it's going to be x minus 1. And then this is just going to be a plus 1. You only have factored out of 1. You get x minus 1 equals 0. And then when you do your GCF, you're going to have x minus 1 is your GCF. All times 4x plus 1. There were some questions like this on it. Was it on the quiz? No, not quiz. Was it on the discussion board? I don't think it was on the discussion board, but it was on. What was it on? I think there was one on your homework about this and on interactive video. Boom. So you have this. Now these are factored out, multiplying equal to 0. So what values can you plug in for x to cause it equal to 0? This one's easy. This is 1. This one, however, you might have to solve it. 4x plus 1 equals 0. Subtract 1 to both sides. You got x is equal to negative 1 over 4. Because you got to divide by 4 in the end. Boom. These are your two values. But the only thing you have to do left now is check the domain of this guy. Right here. In particular, your answer is 1 and negative 1/4. If I were to plug it back in, would I get a negative value? So plug in x. Would I mess up my domain for the square root? So I have x equals negative 1/4 and x equals, is it negative 1? Positive 1. Positive 1. If I plug any of these answers in, you can verify that for me, is that your domain will work. It will work in your domain. So in this case, your solution is actually both your answers. Let me see. Does the domain work? Let's try it out. Let me write the original equation. How do I copy this? I believe I can. I can do this. No, I cannot do that. Let's actually plug them in to the original. So the original is 2x. Original is 2x equals, where is it at? 2x equals 1 minus square root 2 minus x. Let's check if these work or not. Which ones I have to cancel out. So boom, boom. Let's plug in 1. 2 times 1 equals 1 minus square root 2 minus 1. All right, 2 is equal to 1 minus square root 2 minus 1. What is that? 1? Ah, I see where it went wrong. And the square root of 1 is going to be 1. So 2 is equal to 0. This is not true. So we can cancel out x equals 1. Cross that out. Now we got to plug in x to the x equals negative 1/4. So let's try that out. So we have 2 times negative 1/4 equals 1 minus square root. What was the value? 2 minus 1/4. 2 minus negative 1/4. All right, and this is going to be negative 2 over 4 equals 1 minus square root 2 plus 1/4. And now if you add these together, the fractions, so hopefully you remember how to add fractions. This is negative 1/2 equals 1 minus square roots. Is it 8/4? 9 over 4? Check my math just in case. And you have negative 1/2 is equal to 1 minus. If you square root this, if you look at your square root property, this is the same thing as saying square root 9 divided by square root 4, which is exactly the same as saying negative 1/2 is equal to 1 minus 3 over 2. And 1 minus 3 over 2 is the same thing as saying 2 over 2 minus 3 over 2, which this is going to be negative 1 over 2. Oh, so this one does work out. Boom. That works out. Boom. So in this case, we have one solution that works. And that solution is going to be, where's that? This one works. The other one did not work out, unfortunately. So you do have to check if your answers work or not. These are what we call extraneous solutions if they don't work. You get the solutions for your math, but then unfortunately they mess up the domain of the original equation. So I think that's a good stopping point for 1.5, and I'll see you guys for 1.6. Take care.